Okay, we've got several different things we need to do. We've got, for this video, I just want to do segment lengths of a circle. So there's 3 types. And the first type is where you have the angle on the inside of the circle. So that would be 2 chords that intersect. So you've got 4 pieces, and those 4 pieces follow a certain rule. In order to solve, you have to do A times B is equal to C times D. Part times part is equal to part times part. That's what we say in class. Alright, so the hardest part is just making sure that you are pulling the information off the right lines. Alright, so if we have this, and we have 6x and 2x, and 12 and 4. Alright, so if I follow my rules, A times B, that's going to be this line that I need to make sure that I put together. So 6x times 2x is equal to the opposite side, which is 12 times 4. Now remember we discussed in class that x times x is x squared. The reason that works is that when you have variables, you add their exponents. So it's x squared. So 6 times 2 is 12, but x times x is x squared. 12 times 4 is 48. Alright, so when we take 48 and I have to divide that by 12 to get that x squared by itself, I get 4. So divide this by 12, divide this by 12, that cancels. I'm left with x squared is equal to 4. Now in order to get rid of that squared, I have to square root both sides. Those two things are inverses of each other. So the square root of 4 is 2. So x would be equal to 2. That's all it is for an inside angle with 2 chords. Alright, 2 more examples. We've got a circle that has 2 secants. So when I have 2 secants, I follow the rule that says outside times whole is equal to outside times whole. So that means A times A plus B is equal to C times C plus D. Outside times whole is equal to outside times whole. Alright, so if I have a problem, let's see, I've got 2 secants, and my problems will be, let's see, 7, 13, 4, and x. Alright, so if I look at this problem, I'm going to do outside times whole. When I say whole, I have to add all of it together to get my whole piece. So that's x plus 4. Then I'm going to have on the outside 13 plus the whole piece, 7 plus 13. Okay, so I have to distribute. When I distribute, I've got 4x times 4 times x is 4x. 4 times 4 is 16 is equal to 13 times 7 plus 13, or 13 times 20, which is 260. So if I take that 16 and subtract it from the 260, I'm going to get 244. And then you can divide by 4 and you get 61. So x is equal to 61. And that is for 2 secants. And then the last one is for a tangent and a secant. So for a tangent and a secant, you've got A, B, and C. So it's still outside times whole, so it's going to be A times the whole piece, which is just A. So when you have a tangent, it's A squared times the outside piece, B times the outside piece, which would be C plus B. So it's the same concept as the last one, except now it looks different because of the tangent. So if I do a problem with tangent, I've got, let's see, how about 24 on the outside and 12 in X. Alright, so I've got my outside piece of 24. It's also my whole piece, so I times it by itself, or 24 squared. And then I have 12 times the whole piece, which is X plus 12. Remember, I have to add these two pieces together. Okay, so 24, why did I choose such big numbers? 24 times 24 is 576 is equal to 12x, because I have to distribute and it has to go to both of them. Okay, so then if I subtract 144, I get 432, and then I can simply divide by 12 and I get 36. So x is equal to 36. Alright, those are the three types of segment lengths, and have fun.